All right, in this video we're going to talk about expected value, and your last learning target for this unit is to be able to just determine or calculate the expected value of a random event. So first let's define expected value. I want you to write this down. The expected value is an average value that can be found by multiplying the value of each event by its probability and then summing all of the products. Okay? So get that written down, pause the video if you need to, and then I'm going to go through an example here. Berkeley Animal Shelter, there are 25 dogs with litters of puppies. The sizes of the litters are shown in the dot plot below. Each day the veterinarian randomly selects a mother dog and checks the health of each of the puppies. Okay, so we want to find what's the expected number of puppies to be checked tomorrow. Okay, so we're going to basically average. So she might select 2 puppies, 3 puppies, 4 puppies, or 6 puppies. So you have to find the probability of each of those things. So first of all, we have to figure out how many total dots there are here. So 1, 2, 3, 4, 5, 6, 7, 8, 9 plus. So there's 9 here. There's 1 less here, so I know that's 8. This is 3, and this is 4. So adding all that together, that's 24 total puppies. And so here we've got 4 out of 24 for 2 puppies, or 1/6. For 3 puppies, we've got 9 out of 24, which we could divide by 3. That would be 3/8. 4 puppies was 8 out of 24, which we could make 1/3. And then 6 puppies was 3 out of 24, which we could make 1/8. Okay, so there's the probability of each one. So this is the probability of getting this size of litter. So different dogs have puppies, and we want to know what's the expected number of puppies to be checked tomorrow. Okay, so we take the value, so 2 puppies times 1/6, which is 2/6, which is 1/3. I did this in my head. 2 over 1 times 1/6 equals 2/6. So that equals 1/3. This one will do 3 over 1 times 3/8. So that'll give us 9/8. And this one will do 4 puppies, 4 over 1 times 1/3, which gives us 4/3. And then 1/8 times 6 puppies gives us 6/8. Okay, so then we have to add all these things together. And remembering back to fraction work, we need to have a common denominator. So we need to go back to 24 for our denominator. So this will be 8/24. This will be 27/24. This will be 32/34, and this will be 18/24. So adding that all together, 8 plus 27 plus 32 plus 18, I get 85/24, and then I want to divide that 3.54. So approximately 3 to 4 puppies. That's our expected value. Okay? So let's look at example B. A bag contains 1 blue marble and 2 red marbles. We want a tree diagram to picture all possible outcomes and probabilities if you draw 2 marbles without replacement. Okay, so we're going to look at, we might determine the number of red marbles you can expect to draw if you draw 2 marbles. So our first one that we can draw out is either blue or red, right? So our first draw starts with either blue or red, okay? And in that first draw, it's more likely that you're going to get a red than a blue. There's 1 blue and 2 red. So I would have 1/3 and 2/3 as my probability. And then it says, we're going to draw again. So if we already drew a blue, then we have 2 red marbles left. So we're either going to draw, so our chance basically of drawing out a red for our second one is 100% chance, right? So 1. Because either way, either of the 2 marbles that you could draw out would be red. So it would be a 50, so you could do a half and a half, but it'd basically be a 50% chance for each red. So we can just count this as 1 outcome after you've already drawn a blue one for the first time. So multiplying those together, the chances of getting 1 blue and then 1 red is 1/3 times 1, which is a 1/3 chance. Okay, but we don't really care about this because so then from here we have a red, and then we could get a blue or we could get a red. So if a red's already drawn out, the chances of getting a blue are 1/2 because there's 1 blue and there's 1 red left. And then for this one, same thing again, red and red, the chances of getting a red after this are also 1 out of 2 marbles. Okay, so the probability of getting a red and then a blue is 2/3 times 1/2, which is 2/6, or 1/3. And then the probability of getting a red and then a red would be the same thing, so 1/3. And when we look at these, it's good because they all add up to 1. Okay? So determine the number of red marbles you can expect to draw. So determine the number of red marbles. So in this one, you draw 1 red marble. In this one, you draw 1. In this one, you draw 2. So we would take 1 marble times 1/3 plus 1 marble times 1/3 plus 2 marbles times 1/3. The value of that outcome, so we're looking at how many marbles we're going to draw, so 1, 1, or 2, and multiplying that by each probability. So that would be 1/3 plus 1/3 plus 2/3. So 4/3, or 1 1/3 marbles. 1 1/3 red marbles is our expected outcome. Expected value, I just wanted to talk about really quickly. Expected value is usually not going to make a lot of sense in the real world situation because obviously there's no such thing as 1 1/3 red marbles. But what this means is we're more likely to draw out 1 marble than 2, which we can see from this outcome. But basically I'm going to show you in a little while how, or in class, how we can really use expected value to figure out more complicated situations. All right, before class, from the example above, I want you to find the number of times you can expect to draw a blue marble. Okay?